Hello, my name's Frank today, and well, my name's Frank every day, but today we're going to do simplifying rational expressions, an introduction to that. So a rational expression is a quotient, and we're going to learn how to take it and simplify it. So we're used to doing this. We take rational expressions like 2/4 and reduce it down to 1/2. So we've done that before in fractions, reducing, but today we're going to incorporate a little algebra into it, some variables. So what I have today is 6 examples, or really 7, and the requirement for today is you should have a little bit of factoring skill. So we're going to assume you do, and we're going to simplify it by factoring first, breaking it down, and then dividing it out. So let's look at our examples. Now, the first one, we can do these type of problems in different ways. Way 1, we can divide 9x by 9 and 36 by 9. We can do it that way, or we can divide it by factoring. Today I'm going to talk about the factoring approach because that'll be consistent for all the problems today. So let's look at the first problem. Notice the numerator has a greatest common factor of 9. You can divide 9 into 9 and 9 into 36. So the approach we're going to take today is we're going to divide a 9 out. So 9 divides into 9x with an x left out, because 9 times x is 9x. And 9 goes into 36 4 times. Now you can check this by distributing, and you'll get 9x plus 36. And then you divide it by 9. Now 9/9 is 1, so it cancels itself out, divides itself out. So the 9's disappear, and what you're left with is x plus 4. And that's the answer to the first problem. Now you could have got that same answer by just saying 9x divided by 9 is x, and 36 divided by 9 is 4. So you could have done it that way, but I want to be consistent with all of the examples today by factoring. All right, our second example. We noticed that 5 will divide into all these terms. So 5 will go into 5 will go into 20, and 5 will go into 15. So what we do is we will factor out that 5. It's called the greatest common factor. And 5 goes into 5x, x times. If you multiply, 5x. 5 goes into negative 20 4 times. We put the y. 5 times negative 4 is negative 20. And then 5 goes into 15 3. And you can check that by distributing 5x minus 20y plus 15, and there it is, and you divide it by 5. And then the 5/5 divides itself out by 1, and you're left with just 1 times the numerator parentheses, which is the parentheses, x minus 4y plus 3. Now you could have done that by just quickly dividing 5x by 5 and getting x. Negative 20y divided by 5 is 4y. And 15 divided by 5 is 3. So that would have been the quicker way, but the consistent way is to factor here. Okay, our third example. Looking at the numerator, you notice both terms have a y. This has y squared, this has y. So we can factor out a y. And y goes into your first term, y times y is your y squared. Y goes into negative 24y, negative 24 times. So let's check that by distributing y squared minus 24y. And we divide that by the y. The y's divide out by 1, and you're left with 1 times 20, the parentheses. 1 times what's in parentheses is simply y minus 24. And once again, we could have done that by saying y squared divided by y is y. and negative 24y divided by y is negative 24. So these first two examples, you could have done it by two ways, but the next four examples, you can only do it by factoring. So that's why I chose the factoring approach first. Okay, let's look at this example. There is no GCF. Yes, y is in the first two terms, but not in the third one. So we factor that by quadratic factoring, which I hope you've had, y and y. This sign being plus tells you the signs are the same. This sign being plus tells you they're both plus. And we need two multiples of 5, which add up to 6. And that's 5 and 1. And if you were to multiply this out by what's some called a FOIL approach, you'll notice you'll get 5y and 1y, which adds up to 6y. You divide that by y plus 5, and notice the y plus 5s divide out to be 1. Some people say it cancels itself out. And you're left with 1 times y plus 1, which is y plus 1 as the result. Now notice you couldn't have done that, you couldn't have divided this like you did before. So that's why I encourage you to factor if you can. All right, our next example is another factorization, but in this case both numerator and denominator will factor. There are no GCF in the first one, there's none. There's a y, but not in that last term. And in this bottom, there's no GCF. So we factor the numerator with y and y. This term being negative tells you the signs are the same, so we need two numbers that multiply to negative 18 that add up to 3. And hopefully you have a pretty strong factoring base. And you notice that 6y minus 3y will give you that positive 3 in the middle. And 6 times negative 3 is your negative 18. The bottom has no y in the middle, and that has a special name, which I hope you've heard, the difference of squares. Y times y would be y squared. 3 times 3 is 9, and you want 1 to be plus and 1 to be minus, and that causes your y term, 3y minus 3y, to disappear. And then your y minus 3's divide out, and you're left with your y plus 6 over your y plus 3. Okay? Our next one is another factorization, but in this case, again, there's no GCFs. So you factor the numerator as y and y. This sign's negative, meaning one's plus and one's minus. So what are two numbers that multiply to 20, to negative 20, that add up to negative 1? And you'll find that to be a negative 5 and a plus 4, because this is 4y and this is negative 5y, which adds up to negative 1y. Your denominator will be a y and a y term again. This tells you they're plus minus. Two numbers that multiply to negative 45 that add up to positive 4. And it'll take you possibly a while to figure it, but you'll eventually come to 9 and 5. This will be a 9y. This will be a negative 5y, which adds up to your 4y. And then the y minus 5's will disappear, and you're left with y plus 4 over y plus 9. And there's your conclusion. And our last example is possibly easier than the previous one. The numerator is already factored. It's y minus 2. But in this case, we have a 2 as the leading coefficient in front of your square term, which makes it a little harder. You put your 2y and y, and you know your signs are plus and minus, but you don't know where to necessarily put them immediately because these two terms have to add up to -1. So what you'll notice is in a lot of tailor-made textbook problems, the idea is to simplify, which means to divide out, cancel out. So I always tell students, try that y minus 2, like maybe the idea is that these are going to divide out, let's see. And then this would have to be plus 3 because 3 times -2 is your -6. And sure enough, this -4 plus 3 will add up to that -1, and there it is. So if you were to FOIL this out, you would get this expression, 2y squared minus y minus 6. The y minus 2's divide out. So you put 1 remains at the numerator and 2y plus 3 in the denominator. So there you go. It's 1 divided by 2y plus 3. So that's the first start of simplifying rational expressions. I hope you found this informative, and I'll see you next time.